Hello, today I'll be doing problem 10 from chapter 15. This asks us to basically calculate the magnitude and direction of the three particles here. So let's assess the problem. Because guess what? I drew a diagram. Yay! So anyway, here's my diagram. I find that drawing a diagram for me is will help. It helps me a lot because I get to understand it from my own perspective. So I labeled the points and just labeled everything. Also, I converted, as you see, I converted the centimeters into meters and labeled all my forces. So, particle the first particle one between particle 1 and particle 3 is going to be force 2. The two positively charged particles are going to be force 1, and the particle between the positive and the negative is force 3. Let us begin. First off, you just have to use Coulomb's law. Force equals Coulomb's constant times both absolute values of your particles equals over radius squared. Now you have to plug in all your variables and you have to find out what kind of force they are, because that's important. Because the key to solve this, you're going to have to find what kind of forces are repulsing each other and what kind of forces are attracting each other. So the first one is definitely repulsing each other because it's between the two positively charged particles. And that's going to be, I think you can't see that, but that is about, hold on a minute, about 89.9 newtons. And this is repulsive, so please remember what forces are repulsive and what forces are attractive. The second one, again, force is going to be between the farthest positively particles, and this distance is going to be 5 centimeters, so it's going to be 0.05 meters. So please remember to add them together. Plug it in and you get 43 newtons, and then you take the last one, which is going to be the second particle and the third particle. Plug it in and you get 67 newtons. Note I rounded because rounding is awesome. These forces are going to be attractive. I don't know if you can read that. My handwriting's sloppy, so I apologize dearly. So first you're going to have to figure out which ones are repulsive and which ones are attractive. The first one is that the first force together is going to be repulsive, but you have to find out which one it is. So so you're going to have to subtract force 1 and force. We're going to have to subtract force 1 from force 2 because they're repulsing each other, and you're going to get 46.9 newtons to the left. Why? Because the one with the bigger charge is always going to be the most powerful one. So then you have to add the other ones. Easy. You're gonna have to add force 1 to force 3, and you get 156.9 newtons to the right. And then you get, because they're attracting, and then you finally add the 67 newtons plus 43 newtons to get 111 newtons, also to the left. I hope this is helpful for you guys. Good luck on your test, and always remember what kind of attraction or repulsive forces that each particle has. Bye.